Okay, Assalamualaikum and good day, guys. So, I'm going to give you the guide for Lab 2, right? So, in this Lab 2, we're going to learn about Verilog. So, we're going to learn how we can develop a circuit by using Verilog language, right? So, you're going to follow the same procedure as you guys did in your Lab 1. So, create a new project, then you guys can give the name of your project. For an example here, I'm giving my project name as Lab2, right? So and then please make sure that you guys start your project name with a character, not a number. And then the next step is that for you guys to create a new file. Alright, so in this case, just press the like a paper symbol here, and then you're gonna get this pop-up in this window. Then you guys have to choose Verilog HDL file. Don't go and pick system Verilog, right? So it's just a different language that we're gonna use. So in this case, we're gonna use Verilog HDL. So you just pick Verilog HDL and then click OK. Then you guys gonna get a new window, and then what you're gonna do is just so this is the example. I'm giving you the example of how we can do the same circuit as you guys did in your lab 1, but here in this case we are using coding, which is Verilog coding. But I'm not going to do the whole gate, so I'm just giving you example of 3 gates. So you guys have to complete it in this lab 2 session. Alright, so after you guys have done entering all this code, then next step is you save it and make sure the name here, like the module name has to be the same as your Verilog file.v, and then also your project file name. Alright, so when you guys done with this, and then press compile. Right, so in this case I've already compiled, so I've got no error. Right, so and then just want to you guys can also simulate it to see the result. Same step, just do the simulation process like what I've shown in lab 1 previously. But in this class I want to show you guys so the features of quarters, right? So you guys can see how the circuit being constructed in the FPGA. So just click here. Okay, you guys, example here, right? So you guys are gonna see all these the compiling process. So in this case we want to see how the circuit looks like. So go to Fitter, Place and Route, and then double click on Technology Map Viewer Post Fitting. So you guys gonna see like in the block diagram like this. So as you guys remember, we have 2 inputs, right? A and B, and then we have 3 outputs. Output for OR gate, AND gate, and also NOT gate. So as you guys can see, if you double click here, then you can see they're using the OR gate here. Double click here, and then you can see they're using AND gate here. But for out for the NOT gate, so you can see they're using inverter here. So you can see the source from and then the symbol inverting the input. Alright, so this is how we can check whether how the circuit looks like on the FPGA itself. Alright, so if you guys done this, then you guys this is just for FYI, your information, so that you know how to use the quarters tool. Right, so if you guys completed this part, then the next task that you guys have to do is that you guys have to complete all the exercise being given in lab 2. Alright, so I'm giving you tips, alright, so how you guys can work on this exercise. So example here, majority function is a system will accept when there are more ones or zeros on the input. Design a 4-bit majority function. Right, so what you guys can do is that just guys go to Google and then just type Verilog majority function. So in this case I found one, right? So Verilog implementation of majority function. So I click on it, then I got this. Alright, so you guys get this web page. So here they teach you. Alright, so if you think about it, those simple terms, that the input example is fairly simple. So there are three situations that will result in a true. Right, so this is the circuit. So in this case here, so they have wait, how many inputs here? So X, Y, and then all with Y and Z. So X, Y, Z. Alright, so in this case we have three inputs, X, Y, and also Z. So X and X is the input X and Y input to AND gate, and then the output is okay. I'm going to show you an example how we can do this, right? Okay, so we know the answer here, right? But remember, if you guys notice in the lab exercise, they are asking you to do 4-bit majority function. So you guys have to, you know, expand it. Alright, so now, okay, what to do? Okay, so here, I mean, you guys completed the first part. So the first part is that you have to complete the example as in lab 1, right? So here is your lab 1. So you have to develop the whole circuit like this, but using Verilog. I'm showing you example for 3 gates, XOR and also NOT. So you have to complete those all those gates there. Right, so when you completed that part, and then we go to the second part where you have to complete all the exercise, right? We'll see how far you can go. So I'm showing you example how to work on the exercise. So create a new project. So new project wizard, and then okay, you just close lab 2. Alright, so press next. Alright, so still in lab 2. Okay, so in this case we want to create another project. So what is the project name? We name it as lab 2 exercise 1. Alright, lab 2 exercise 1. So press next. Okay, right, so we have, it's better for us to create a new folder. So quarters, so let's create a new folder, lab 2 exercise 1. Alright, so select folder. Alright, so next. So in this case I'm just using whatever it is, because it doesn't matter, we just work on the simulation part, right? Okay, now, so I've completed this. So you guys have two options. Either you can try to find a complete code, you know, for the answer, or you can just use, you know, the hints that you find from the website. So it's really up to you, right? So okay, in this case, so let's say you want to do the exercise number 1. So same process, create a new file, Verilog HDL, and then okay. Alright, so we can use the same code as before, but we have to modify it a bit. Alright, so if you guys remember, here they are saying that we need to have 3 inputs, X, Y, and Z, and also we are using 3 gates, 3 AND gates. Okay, let's work on it. Alright, so input, you can change the names to whatever that you want. So we have 3, X, Y, and also Z, and then in this case we only have 1 output. Let's say we put out, alright, or just put A as the output. Alright, so in this case we are, okay, let's look at here. So X and with Y. Alright, so we're using AND here, AND gate. So this is the output. So the output is A, and then here the M input is X and also Y. Right, then the second one, we continue the second one. So we just do this first, later we're gonna modify it. Right, so y and z, y and z, y, and so z, and also the third one is x and z, x and z. Alright. Okay guys, so fast forward, so I've already edited the code. So as you guys can see, I changed the name here to lab exercise 1 following my project name. So I have 3 inputs, which is x, y and z, and also I have one output. But in this case, I'm using wire. So I'm using 3 wires, N1, N2 and 3, where I'm going to connect N1 wires to output of this AND gate. So actually guys, I mean, this is something that already being fixed. Alright, so N is a function, that's why you see it's a blue color. So the function is that N, so the first one has to be output, right? So this is the output, and then this is gonna be input 1, input 2, input 3 and input 4. So it depends how many inputs that you have, but you're gonna only have one output here, so it's a fixed function. So that's why here we insert N1 as the output, and the following then input X and also Y. So same goes here, we connect to another wire, which is we name it as N2, and we connect it to the output of the second AND gate, and then the third one we name it as N3. Here the OR gate, so we here's the output of the OR gate, which is A, and then the input of the OR gate is N1, which is the output from AND gate 1, and then N2, which is the output from AND gate 2, and N3, which is the output from AND gate number 3. So we completed it. Then you guys can compile it. So after you compile it, then you simulate it to check whether it's correct majority function or not. So in this case, I've already run the simulation, and then here's what I got. Okay, see, let's check the output, right? So you guys can zoom it a bit. Zoom in. Alright. So as we can see, right now we have 3 inputs, x, y and z. So as y is 1, and then x is 1, y is 0, z 0, then the output is 0, because it's not majority, right? So we have 3 inputs. The input has to be more, the input that is 1 has to be more than 1, which is 2, right? So in this case, if 1 is not majority yet, so x, when x is 1, y is 1 and z is 0, then we see the output is 1. So whenever the input is majority, then it's going to be 0. So if you go reverse way, so if here in this case the input is 0, then the output is 0. Then when there are 2 inputs that are 0, then when there are 2 inputs are 0, then the output gonna be 0. Alright guys, so this is the example how you can complete exercise number 1. So go ahead and try to complete. You just can try to Google. So like example here, question number 2, right? Design a digital circuit which generate 5-bit input number into 2's complement value. So just find Google Verilog 2's complement, right? The same goes as number 3, and then goes up until you finish the whole exercise until part B. Alright, so thank you so much guys. So this is the guide for lab 2. Hopefully you guys can complete it within the given time. Alright, thank you so much.